Alright, today we're going to be talking about cardioids and limacons. Okay, all cardioids and limacons require 0 to 2 pi to form one complete graph, by the way. So cardioids are heart-shaped, and the word cardioid even has that little heart prefix thing going on. So they're heart-shaped, but they are nice, chubby hearts. Okay, we want no skinny hearts. All right, limacons they might be a little kidney shaped, or they might be heart shaped with a little loop. Okay, there are two types of limacons: kidney shaped or little heart shaped with loops. We call these regular limacons, and these are limacons with loops. All right, so let's talk about cardioids. So the equation of a cardioid looks like this. So it's like we took our circle equation and we're adding a number to it. Okay? A cardioid has A and B. They are equal absolute values. So the absolute value of A is equal to the absolute value of B. Okay? So they're always heart-shaped. They always go through the origin. And remember, nice and plump. Okay? These are super easy to graph. This is if you don't have me sitting here telling you, but I'm not going to go and read that to you. We're just going to go and graph some. Okay? So, for this one, I see a sign and I see a plus. So I think to myself, the bulk of the cardioid is on the positive y-axis. Positive sign. Positive y-axis is the bulk. So I know the bulk is going to be coming on the positive y-axis. And it is 3 plus 3 units long. I'm ignoring this plus right now. All I'm doing is taking the absolute value and the absolute value of 3 plus the absolute value of 3 is 6. That's how far up we go. Okay, that's the bulk of it. This number tells you how far side to side to go. So we're going to go 3 side to side. 3 side to side. Okay? And then we go through the origin and draw your heart. Nice and plump. Right out here, you guys, it's fairly flat. Not flat, but it's very, very curvy. Okay? It's not like no points out here. It's very curvy. Now yesterday I talked about there's no bouncy bounces. This is an instance where you do get a bouncy bounce, and it's right there. It's always right at the origin. No other bouncy bounces though. Alrighty? Okay, this one. Negative cosine. So the bulk of this is on the negative x-axis. Okay? So negative x-axis, how far out? 2 plus 2. Ignore the minus. 2 plus 2 is how far out you go. So 1, 2, 3, 4. How far side to side do you go? You go side to side 2. So side to side 2. Go through the origin and draw your curve. Like that. A little heart-shaped, sideways heart. Okay, negative sign. Negative sign, so negative y-axis. How far down? 8. 1, 2, 3, 4, 5, 6, 7, 8. If you have to go off the curve, off the axis like that, go for it. Side to side 4. And through the origin. something like that. It does not have to be perfect, but I do expect it to be nice and plump. This is an actual one, the way it should look. Alrighty. What is the equation for this? R is equal to what? Well, it's on the positive x-axis, so I know it's going to be a plus, some number plus cosine, a cosine, right? Okay. We go up and side to side is 3, and side to side is always that first number. So side to side 3, side to side 3, plus, okay? Now I'm going to have a number in front of my cosine, so I'm going to leave a space, but it is going to be a cosine of theta. There's never a number in front of the theta when you're doing a cardioid. For a cardioid, this has to match. Has to match. The absolute values have to match. Okay? I didn't mention something back when we did this one. There was a -4 out here, right? That has no effect on the final graph. It only affects how it is formed, not the final graph. So for this one here, we could write this as -3 plus 3 cosine theta. Either one of those is true. Okay? I'll let students read this before we go on in class. I will let you read that, but I'm going to go ahead and go on. Alrighty. So those are the cardioids, and now we're going to talk about the Limacons. Now, Limacon is a French word, so it is pronounced in the French way. It is not a Limacon. It is a Limacon. Okay? You can even say it with a little French flair if you prefer. So a Limacon. Alrighty? Limacon. Say it with a little French attitude. Alright, a Limacon has the same basic form of the equation as a cardioid, only A is not equal to B. Okay, there are two kinds of Limacons. In one kind, the absolute value of A is larger than the absolute value of B. In the other kind, the absolute value of A is smaller than the absolute value of B. If A is bigger, you have that kidney shaped. You do not go through the origin. It goes outside the origin. If A is big, you're so big that you go outside the origin. You don't even touch the origin. Okay? Don't even touch the origin if A is big. Okay? Let's go through some examples. Negative sign. Just like with cardioids, negative y-axis is the bulk, and we're going to go down 6 to get there. 4 plus 2, 6. Side to side, 4. Side to side, 4, just like cardioids. Okay? Now, the 4, and I'm ignoring the minus. The 4 is bigger than the 2. 4 is larger than 2. So this goes outside on the positive y-axis. How far outside? How far outside is 4 minus 2? 4 minus 2. I'm ignoring this minus here. You always do this. Even if it's a plus, you're going to go this number minus the absolute value of that number. Okay? So we're going to go out 2 units. And that's going to be our little kidney indent. Okay? Now I will say on some of these you get an indentation here, like a little dimple, but on some of them it depends on how close these numbers are. On some of them you don't even get a dimple. It doesn't even look like a dimple. Look at this curve over here. Does it look like there's a dimple right here? No, it doesn't. Sometimes you get a dimple, sometimes you don't. I don't care if you draw it with a dimple or no dimple, okay? I'm going to be looking at how far out you went, all right? Here we go side to side 4, we go up 2 and down 6. Okay? Positive cosine. Positive cosine, so positive x-axis. How far out? 3 plus 1. That's how far out on the positive x-axis. So go out 4 units. Okay? Side to side, 3. Side to side, 3. Three is bigger than 1, so we go outside the origin. Outside the origin, how far? 3 minus 1 is 2. We go outside the origin 2 units. Okay, so this is 3 out, 3 down, 2 back. Okay, and then draw it. And again, I don't care if you draw it with a dimple or without a dimple. It doesn't have to be exact. I'm looking for these values here. All right. That doesn't look very good, but whatever. It's done. Okay. Positive sine. Positive sine, positive y-axis. How far out? 7. That negative will not affect the final graph. We go out 7. So 1, 2, 3, 4, 5, 6, 7. Okay. Side to side, 5. Side to side, 5. 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. 5 is bigger than 2. 5 is bigger than 2, so it's popped out, not through the origin, it's popped out 3 units. 5 minus 2 is 3. 3 units. And draw your curve. Oops. Draw it through the right point. There we go. Okay, one more. Positive cosine. So positive x-axis, 9 units out. Five units side to side. And 5 minus 4 is 1, so only 1 unit over here. This one will definitely have a dimple. I can tell they won't have a dimple. The further out you go, the closer these numbers are. The closer these two numbers are, the greater chance you have of having a dimple. Okay, FYI. Alrighty, let's write the equation of this graph, of these graphs now. Okay, the first thing I notice is positive x-axis. So I know I'm going to have a plus cosine. Plus cosine. Alright, side to side 3, that gives us our first number. Plus, because positive x-axis. Okay, what number comes here? Well, how far out did I go? I went out 5 units. 3 plus what is 5? 2. 3 plus 2 is 5. Cosine theta, and we're done. We could also have written negative 3. It would be the same resulting graph. Okay, this one. Negative y-axis, so minus sine. How far side to side did we go? We went side to side 5. Minus sine. Minus something times sine theta. What number? Well, how far out do we go? 1, 2, 3, 4, 5, 6, 7, 8. We went out 8. 5 plus what is 8? 3. Or negative 5 minus 3 sine theta. Either one will get you that graph. Okay? The bulk of this one lies on the negative x-axis. So I know it's going to be a minus cosine. Okay, side to side, 4 units. Minus something cosine theta. Okay, 1, 2, 3, 4, 5. We only came out 5, so 4 plus what is 5? Well, 1. So this is like a 1 here. I'm not going to write a 1 in front of cosine, but it's a 1. Or r is equal to negative 4 minus cosine theta. Okay, one more like this. Alrighty, side to side, 4 units. Positive y-axis, so plus sine theta. What number? We went up 1, 2, 3, 4, 5, 6, 7. 4 plus what is 7? 3. Or negative 4 plus 3 sine theta. Okay? Again, read this down here. If this number is not a plane theta, you do not get a cardioid or a limacon or anything like that. Okay? You get something different. A very fun, like, rotated daisy that does not go through the origin. Fun stuff. You should play with that on your calculator or on Desmos. Alright, one more type. Limacons with a loop. Limacons with a loop. So a limacon with a loop is when the absolute value of A is littler than B. I think if A is little, then you have a little loop. So in comparison to B, if A is little, if your number alone is little, then you have a little loop. Okay? If you have a little loop, you always go through the origin. Little loops will go through the origin. Okay? Alright, so let's do some. Limacon, little loop. 1 is littler than 3. 1 is littler than 2. 2 is littler than 5. 3 is littler than 4. So these will all have little loops, okay? But to graph them, we're going to do exactly what we did before. So I'm thinking positive sine, positive y-axis. How far up? 4. How far side to side? 1. Little loop goes through the origin. You can think of it as 1 minus 3. What is 1 minus 3? 1 minus 3 is negative 2. Negative 2 goes inside your shape. How far inside? 2 inside. So now we're going to draw this. I will warn you that on these you have very little showing underneath that x-axis there. Okay? So when you draw this, I like to actually draw my little loop first. And remember to try to keep it nice and smooth. So like that, there's our little loop. We come around here, come around, keep going around, you're almost there, finish it up. There's our limacon with a loop. Notice that these loops are nice and curvy. There's no bouncy bounces. No bouncy bounces at all. Okay? Negative cosine. So negative x-axis. How far out? 3. 1, 2, 3. How far side to side? 1. How big is our little loop? It goes through the pole. 1 minus 2 is negative 1, so it is of 1 unit long. It's 1 unit. So we draw it, draw our little loop. Nice and smooth. Nice and smooth. So nice. Those are both pretty darn good. Got a little wonky here, but pretty darn good. Okay, negative sine, negative y-axis. How far down? 7. How far side to side? 2. Two minus 5 is negative 3, so inside your figure 3 units. That's going to be our little loop. So our little loop is going to actually be kind of a fat loop. Something like that. Okay? All right, one more, negative cosine. So negative, the bulk is on the negative x-axis. How far out? 7. 3 plus 4 is 7. How far side to side? 3. Little, at 3 is littler than 4. So it goes through the pole. How far through the pole? Negative 1 unit, so 1 unit. It's a tiny little loop. Like that. Alrighty, let's write some equations. So it's harder to see where the side to side is on graphs with little loops. But we know it's there, so we go and find it. So right here, I see it at 2 and negative 2 here, right? 2 and 2, I mean. So this is going to be r is equal to, the first number is 2. Okay? Negative x-axis, so minus cosine, right? We need to find this number. This number plus this number will be our how far out we go. So that's how I do it. 1, 2, 3, 4, 5, 6, 7. 2 and 5 is 7. So that would work for this one. Or negative 2 minus 5 cosine theta. Okay. For this one, another 2 and 2. So r is equal to 2 positive y-axis, so positive sine. How far up? Well, 1, 2, 3, 4, 5, 6. 2 plus 4 is 6. Or negative 2 plus 4 sine theta. Okay, this one only goes side to side 1. So r is equal to 1. Another positive y-axis, so plus sine theta. How far up do we go? 1, 2, 3, 4. 1 plus 3 is 4. One more. Okay, side to side, 1 again. Positive cosine, so plus, positive x-axis, so plus cosine. How far out do we go? We went out to 5. 1 plus 4 is 5. Okay, and once again, the theta coefficient must be 1 for you to have a Limacon with a loop. If it's not, then you're still going to have little loops. Aren't those cute? I'm telling you, you should go play with Desmos or with your graphing calculator and see some really fun shapes. Okay? Find out what would happen if there was another theta. What would happen if you had a tangent? What would happen if you had a different trig function? Okay? These get super interesting. I think this already is interesting, but it can get even more interesting. So go play on your calculator. I think that's it for these notes. And so that's it for the graphs that you are responsible for knowing. So you are responsible for knowing the circles, roses, cardioids, and limacons.